Okay, nice to see you again. So in today's problem, we are going to solve for internal forces and moment diagram. So in this kind of problems, what you need to do is first that you need to find a reaction forces and then try to make sectioning, yeah, and then plot the internal forces and moment diagram. Okay, but in this problem, you will be also asked to solve internal force and moment at point C. Yeah. So let's do first by drawing the free body diagram here. So let's say this is the beam, and then there is a 2 kilonewton, and then here at point B, because this is roller, you will have By. Okay, and then at point A, you need to replace with a force Ay and Ax. Am I right? I guess so. And then here you will have 4 kilonewton, and then you will be asked to calculate the force here at point C, which is in the middle, right in the middle of the beam. So first, let's find the reaction forces. You need to apply the equilibrium equations. In this case, if you take sigma moment at point A, because here at point A you have two unknowns, it's always better to take moment or to evaluate the moment at the point where you have a lot of unknowns, so you can simplify the problems. So here, imagine at point A, the 4 kilonewton will create clockwise, so it's minus 4 times the distance, yeah, this distance to this distance, which is in this case 2 meter, and then the By will create a counterclockwise positive By times 4, and then you'll have clockwise moment 2 kilonewtons times 6, yeah, because the distance from here to here is 6 meter, this is 2 meter, and so on, yeah, and they are equal to 0. So if you divide by 2, so you will have 2 here, you will have k, and then your divide again by 2 again, you've gone here, you have 2, here you will have 3, so your By will be equals to minus 3 and minus 2. Am I right? Yes, you're right. Minus 3 minus 2, so it's 5 kilonewtons, right? That's the By. So let's mark with green color. So this is the first unknown that you get, yeah? And then if you apply equilibrium equation again, yeah, equilibrium equations, for example, sigma fx equals 0, and then directly from this free body diagram we know that the Ax is the only forces working in an x direction, so they are 0, Ax is 0, right? And then sigma Fy equals 0, you will end up with Ay plus By, and then minus 6, right? Minus 6 equals 0. And then your Ay will be 6 minus By. In this case, By is 5, right? So your Ay is 6 minus 5. So it's 1 kilonewton. And that is the second unknown that you found. Oh, this is the second one. And this is the third one. Okay. So now you have 3 unknowns and all of them solve, right? Reaction force, all of them solve. Okay. So now let's say the question wants you to get to the point C. What is the internal forces? You can directly make a cutting at point C. So let's make a section at point C, and then let's take the left part, I guess. So let's say solving internal forces at C. Yeah, what did you got? So let's draw again the left section. You will have Ax, which is 0. Yeah, let's draw it. Ax equals 0. You have Ay, and then you have the 4 kilonewtons, right? So here you have 4 kilonewtons. And then at point C, since you're taking the left side, the convention is you have V, you have N, and then you have M. Okay, that's how you draw the forces due to the sectioning, and it's all complete, right? And then you can use the equilibrium equations. For example, sigma moment at A equals 0. Yeah, so if it's evaluate here, your moment M will be counterclockwise, M and then plus V times the distance. The distance is 3, right? And then M plus this, and then you will have clockwise. No, the V will create clockwise, so it's negative. And the 4 kilonewton will also create 2 clockwise, right? So it's minus equals 0. So your moment will be equals to 8 plus 3V. Yeah. Okay. We still don't know what is V. So let's evaluate V. Sigma Fy equals 0. Yeah. And that means that minus V plus Ay minus 4 equals 0. Right? So your V will become Ay minus 4, where is Ay is 1 kilonewton from the third unknown that you solve. So your V will be 1 minus 4, which is minus 3 kilonewton. And that is V, and this one is at point C, yeah? Okay? And then, since V is minus 3, and then your M will be 8 times 3 times minus 3. So your M will be minus 1 kilonewton meter. All right, and that is the answer of the moment, internal moment at point C. Okay, any questions? And that's how you find internal forces and moment at a specific location defined in your beam. So you directly make a section at that point. That's quite easy. In the next part of the video, we are going to plot the internal forces through the length along the length of the beam. Yeah, so we need to make some sectioning in several places. Yeah, we cannot just directly cut at one location, but the location of the cutting will be a variables. Okay, but that will be the content of the next video. So for this video, I think it's enough to find the internal force and moment at point C. How about N? Yeah, so if you take sigma fx equals 0, ax plus n equals 0, since your ax is 0, your n is also 0. Yeah, so this is the third forces. This is the normal forces, n, yeah, at point C. At point C. Okay, so I think that's it. See you again in the next video about internal forces. Thank you.